In the last section, we finished up our first project, but there's still a lot for us to learn about Flutter. So in this section, we're going to start working on our next big project. We're going to first generate a new project at our terminal using the Flutter CLI, and we'll talk about what we're going to build. So I'm at my terminal, and you'll notice that I've changed into a sort of workspace directory. So I'm no longer inside of the pics folder that we had previously generated. So inside this workspace directory, I'm going to generate a new project by running flutter create and then the name of our project, which is going to be login_stateful, like so. So I'll run that command. That's going to generate a bunch of different files and folders and start installing a couple of dependencies. While that runs, we'll talk about what we're going to build here. All right, so here's what we're going to be making. We're going to make a login form, or kind of a sign-up form of sorts. A user is going to be presented with an email field where they can enter in some email and a password field where they can enter in some password. Then they'll click on the submit button, and that's pretty much it. Now, this application might seem very simple and straightforward in nature, but in reality, there's going to be a lot of hidden complexity in here that we'll talk about in just a moment. The one thing I want to mention is that when a user enters in the email and password and then clicks on submit, we need to make sure that we validate both the inputs that they enter in. So we need to make sure that they actually entered a valid email and a valid password. So maybe the password has to have some minimum number of characters inside of it to be considered valid. To be clear, we are not wiring up authentication here at all. Okay, so there's really no idea of actually signing in a user or anything like that. We're just focused on building a form and validating some inputs that a user provides. Now let's talk about why this is going to be a little bit more complex app, or a little bit more complicated than it might seem at first glance. Okay, so at this point, we've spoken a fair amount about something called stateful widgets inside of Flutter applications. Remember, stateful widgets are used anytime we have some data that's going to change over time, and whenever that data changes, we would want the UI to update. In the last application we put together, we used a stateful widget to handle that interaction. We had a stateful widget that would update some data, and whenever that updated, poof, the screen magically changed. The problem with the stateful widget is that it doesn't really scale up to larger applications that have multiple different screens. In essence, with a stateful widget, it's kind of challenging to pass around data from one screen to another inside of your application. So the stateful widget is kind of seen as kind of an introductory level way of managing state in a Flutter application. It's a perfectly fine way to manage state if you have a simple app. But as soon as your app starts to grow in nature or grow in size, well, it starts to get a little bit complicated and a little bit more challenging. As a solution to this, Flutter designers came up with something called the block pattern. And this is an alternate way of managing state in a Flutter application. Now, there's definitely a lot of different ways to manage state inside of a Flutter app, but we're going to be focusing on this block pattern thing right here because this is the way that is supposedly highly recommended by the Flutter team. And in fact, even in a recent video published by the Flutter team talking about state management, they say very clearly, yeah, we really recommend checking out the block pattern. It's just the best way of doing things. So the reason I'm kind of mentioning the fact that the Flutter team is endorsing this is that there are actually many different means of state management inside of Flutter right now. A lot of different ways of doing it. And no one's really got the expertise to say which way is better than the other. However, the Flutter team has publicly endorsed this block pattern, which is why we are going to go in that direction. Now, the reason I'm showing you this diagram right here is kind of tied back to the application we're going to build. So the block pattern is definitely the way we want to design applications, but it's rather challenging and it's rather complicated to understand. So to give you a really smooth introduction into this block pattern thing, we're going to first build out this login form or this sign up form application using the more classic stateful widget approach, the approach that we just learned in our last application. So we're going to build out the entire application with that approach, and then we're going to rebuild the entire app a second time, but instead use the block pattern. So essentially, we're making this 2 times, but with radically different approaches. So with these 2 approaches, you'll have your own ability to kind of compare and contrast the 2, and you'll have your own opinion on which way you like the most, and whether you want to stick with the more classic but simple stateful widget approach, or use the fancier but kind of harder to understand block pattern instead. Okay, so that's the idea. We're going to build the same app 2 times, and that's going to give you a really strong opinion in which way is best for building any particular application. So let's take a quick pause right here. We'll continue in the next section and get started with our application. So quick break, and I'll see you in just a minute. In the last section, we started talking about the next application we're going to be working on. I'm now back at my terminal, still inside of my kind of workspace directory. I'm going to change into the login stateful that we just created, login stateful folder, excuse me, that we just created, and then I will start up my code editor inside there. I'll then flip back over to my terminal, and I'm going to execute the command that will get our application running on our emulator as well. So inside of my login stateful directory, I will run flutter run. Okay, so that's going to start up the new application we just generated and install it onto the emulator. We'll let that kind of run for just a little bit. While that's going, I'll flip back over to my code editor and we'll get started on our project. Now we have all these different files and folders that were automatically generated for us again, but as usual, all the code that you and I are going to write is going to be placed inside this lib directory. Inside there, we have that main.dart file that was automatically generated for us. Now, as was the case in the last project, I don't really like using all this default code that we get for free. So I'm going to select everything inside of here and delete it. And we'll just start 100% from scratch. Now at the top of this file, I'll first begin by importing that material.dart file from the Flutter library. So I'll do import package flutter material.dart, like so. From this material.dart file, we get access to that run app function. Remember, the run app function is how we get some initial widget to appear on the screen of our device. So inside of here, I'll define my main function, and then I will call run app. And of course, we need to pass in some widget right here to be rendered on the screen. When we first started off our last project, we wrote a lot of widget code first directly into this main.dart file, but we eventually came to realize that, yeah, we should probably separate out all those widgets into different files inside of our lib directory. So I'm going to immediately create a new file that's going to house a new widget that's going to serve kind of as the root widget of our application. To do so, in my lib directory, I'll make a new folder called src, and then inside there, I'll make a new file called app.dart. Great. So now inside of app.dart is where you and I are going to create our kind of default widget, or the first widget that will be rendered on the screen. At the top, we'll first again import our package of Flutter material.dart. I'll create a new class that I'm going to call app, and that's going to extend the stateless widget. Then we'll define the one method that we are required to define inside of here, which is the build method. And this is where we're going to return some other widgets that will be displayed on the screen. The build method is always called with that context argument, which again, I know I've said it many times, but we're going to talk about what that's for here pretty soon. And then inside of here, I'm going to create a new material app. I'll give it a title of something like log me in. And I'll give it a home that is a scaffold widget. And inside there, I'll put some text, or excuse me, a body. I'll give it some text of show a form here, like so. Okay, so now we got something to at least show up on the screen. Let's flip back over to our main.dart file. We will import this and then make sure that we pass it off to the run app function. So back inside of main.dart, at the top, I will import src app.dart, and then we'll pass that thing off to the run app function like so. Okay, so we just went through all that pretty quickly, but it's all the very similar stuff to what we did in our last application. We've now got a main.dart file, we've got an app.dart file. The app creates a material app. When we create a material app, that gives us a couple of very default elements that we would expect to have in any mobile application, such as navigation. And we are saying right here that we want the default component to show up on the screen to be a scaffold that has a body of some amount of text. So if I now go back over to my terminal, I should be able to hit Shift-R to do a full restart of the application. Wait for our reload, and it's kind of hidden up there, but you can definitely see that it says Show Form here. So, good place to get started. Let's come back in the next section, and we'll talk about the login form that we're going to be working on. In the last section, we got started working on our new login form application. So this iteration of this application is going to use those classic stateful widgets to somehow manage the form state and make sure that a user enters a reliable email and password. Now we just created the main.dart file and the app.dart file. We're going to very quickly start to create a couple of other widgets inside of our application, and I want to give you a quick preview of exactly what we're going to be doing. So I put together a diagram that shows all the different widgets that we're going to have to work with. Now you'll notice that in this hierarchy tree right here, at the very top we have the app, which is what we just created, and we've got one other blue square in here, which is this login screen widget. So the two blue things that you see inside of here are widgets that you and I are going to create. Every other widget is going to be a part of the Flutter standard library. So as you can see here, the vast majority of elements that are going to show up on the screen for creating this form are all created and maintained by Flutter. So you and I don't have to manually create these like input elements right here, like totally from scratch and try to work with user input. Instead, we get these really handy widgets called TextFormFields that can be used to receive input from a user and automatically validate whatever the user provided to us. So let's very quickly go through this hierarchy. At the very top, we have the app. We're showing the material app inside there. Okay, whatever. We got the scaffold, whatever. And then the next one is where things start to get interesting. So we've got this login screen widget. The login screen is going to be responsible for showing the entire form on the screen to the user. It's going to be a stateful widget because there's going to be some data generated by the user when they enter in their email right here that we're going to want to use in some fashion. So we're going to make the login screen into a stateful widget. Inside the login screen, we'll show a container solely for styling purposes because we're going to want to have some margin around the edge of this form. Inside of there, we'll use a built-in Flutter widget called a form element. This form right here works in conjunction with these two text form fields that you see down here to get some inputs on the screen and provide some interaction for very common operations that we might want to do around a form, like say saving whatever a user types into the input or validating whatever a user enters in as well. So again, this form thing right here and these two text form fields are going to be working together very closely. Immediately inside the form, we're going to show a column. The column is just so we can lay out a handful of widgets in a column sort of layout, so from top down to bottom. Inside the column, we're going to have the two text form fields and a raised button. The raised button, as you might imagine, is going to represent the submit button down here. The text form fields, again, they are built-in standard Flutter widgets. They're going to show these inputs on the screen. And the reason I'm making kind of a big deal about them is I want you to notice that we don't have any separate widget to show the labels on here as well. So the text form field encapsulates everything you would need for showing a text input to a user. Not only the actual input itself, but also the label for it, and also eventually some validation error as well, like say this red text down here. So the text form field is going to be really the entire basis of our application when it comes to showing the inputs on the screen. All right, so with all this in mind, let's flip back over to our editor, and we're going to get started working on this login screen widget. All right, so back inside of my code editor, inside my src directory, I'm going to make a new folder to house this screen widget that we're about to create. So inside of src, I'll make a new folder called screens. The idea behind this folder right here is that it might eventually house all the different widgets that a user can navigate to inside of our application that form like distinct screens that a user can visit. So in our case, this login screen right here, it's definitely a distinct screen that a user can visit, and so I'm going to create that in the screens directory. So inside of here, I'll make a new file called login_screen.dart. Then inside of here, we'll write out some boilerplate for a stateful widget. At the top, I will import a package from Flutter. I want material.dart, and then I'll make my login screen, which is going to extend stateful widget. And then remember the process that we have to go through for creating a stateful widget. We have to define that createState method, and we have to create that separate class that's going to represent the actual state of this widget. So I'll first begin by making the createState method. Inside of here, I will return a new login screen, excuse me, not new, we don't need that keyword anymore, login screen state. And then underneath this, I'll define that class. So I'll say class login screen state, and that's going to extend state. And remember, we're going to use that generic type syntax. So the state right here is going to have a generic that conforms to the login screen type. So login screen. And then inside of here, we'll define our build method, which is going to return a widget like so. Okay, so good place to get started with just a little bit of boilerplate here. Again, this is all the same stateful widget stuff that we put together on the last application. So if any of this looks confusing, you can always pause the video here and go back to the last application and look all this stuff up. I would give you another big lecture about what it's all doing for us, but we definitely spoke about it in great detail in the last application. So again, if it is confusing, I recommend you go back over there. Okay, so let's take a quick pause right here. We'll come back to the next section, and we're going to start fleshing out this build method right here. So quick break, and I'll see you in just a minute. In the last section, we put together some boilerplate for the login screen widget, and we left off on our build method inside the login screen state. So inside of our build method right here, we're going to want to show a container that's going to have a little bit of margin on it. Again, this container right here is just to get this nice margin around the edge of the screen. And then immediately inside there, we'll show our form. Let's first start with our container by itself, and we'll just show some text element or something like that inside of the container, and just make sure that everything is working as we expect. So back inside my editor, I'll find my build method right here, and I will return a container. I'm going to give it some margin around the outside. And remember, to add margin, we have to create an edge insets object. And I'm going to use the all constructor, which specifies that I want some consistent margin around all sides of this container. And I'm going to say that I want around 20 pixels of space. Then inside of the container itself, like I just said, we'll just add in a quick text widget here. I'll say something like login screen. And then we will save this. You'll notice that my build method right here is still red. It's because I have not accepted the context argument that's always passed into every build method. I know I've said like 4 or 5 times, yeah, this context stuff we'll talk about eventually. When we start rebuilding this application for that kind of block approach that I spoke about a couple of videos ago, that's where this context stuff starts coming into play. So that's where we're going to start saying, okay, here's what context is. Okay, so this looks good for now. I'm going to save this login screen file. I'm then going to flip back over to the app.dart file and make sure that it shows an instance of the login screen. So inside of app.dart, at the very top, I will import screens login screen .dart. And then for my body property right here, rather than showing that text that we had before, I will replace it with a new login screen. Okay, that looks good. So let's save this. I will flip back over to my emulator. I'll do a hard refresh, and we'll see how we're doing. Okay, so I see login screen appearing on here, and I now have a little bit more margin appearing. So definitely good improvement. Let's flip back over to our editor, and we'll keep going inside of the login screen. All right, so like I had just said, inside the container, we want to have this form thing right here. And as we had discussed, the form is going to work very closely with the text form fields to actually make the process of validating these inputs and getting values out of them a little bit more straightforward. So inside of this container that we just created inside of login screen state, we're going to replace text right here with a form instead. So I'll say form, and then I'll open it up. Now we're going to end up doing a lot of stuff with the form, but to get started, we're just going to make a simple form with no special configuration tied to it whatsoever. So we're just going to try to get this stuff to appear on the screen, and then we're going to come back and start to customize this form tag and get a better sense of how we can use it to control those inputs that are rendered on the screen. So for right now, all we really need to understand about this form is that we can give it a child to display on the screen. That's pretty much it. That's all we need to know for right now. So I can add on a child property to this thing. And if we go back over here, remember we want inside the form, we want a column that's going to show the text form widgets and the raised button as well. So inside the form, for right now, all I care about is creating a column that's going to have some number of children. And inside this array right here is where we're going to render the text form field number 1, text form field number 2, and the raised button. So I think this is probably a good place to take a quick pause at. So let's stop right here. We'll come back to the next section and we'll start putting together the text form fields and the raised button as well. So I'll see you in just a minute. In the last section, we added on our form tag right here, and we gave it a child of a column, and the column is going to show some number of children inside of it. Remember, the column is here just to lay out widgets on the screen. That's the sole purpose of the column widget. So now inside this children array, we can create our 2 form text fields and our raised button as well. Now we could definitely add in all these widgets directly to this children array or children list right here. We could do something like raised button and then pass in a ton of configuration to this thing. But that's going to make this children list right here be very hard to read if we try to stick in a lot of stuff on there. So rather than adding in every one of these child widgets directly to children, I'm going to instead make a couple of helper methods inside of our login screen state class. And each of these helper methods are going to produce either the text form field for the email, the text form field for the password, or the raised button for the submit button. So inside of my class, I'm going to go down to the very bottom while still inside of the final closing bracket for the class, and I'm going to add in 3 helper methods. The first one I'm going to call email field. I'll call the second one password field. And then finally, I will also add in submit button. So again, the idea here is that each of these helper methods are going to create the respective field or the button and then simply return them. So all we're doing here is keeping this build method a little bit easier to read by not sticking this huge kind of pyramid of doom of all these nested widgets inside of here. So now in the children list right here, I'm going to call email field for the first argument, first element inside there, excuse me. Then I'll put down my password field, and then finally the submit button as well. Okay, so now each of these can return a widget themselves, and we get to put all the logic tied to them into these separate methods. Let's make sure that we mark each of these methods with a return type as well, just so it's really clear that, yeah, the email field is going to return a widget that can be shown on the screen. So I'm going to mark this as a widget, and a widget as well. Okay, so that's good progress. Now we'll get started immediately with our email field. For this, I'm going to very quickly bring up the documentation for a text form field, and we'll get a better idea of how they work. So back inside of my browser, remember we can access our documentation by going to flutter.io/widgets. And that will open up the widget catalog. So inside of here, we can either try to hunt and peck inside of all these lists, or we can just do a search from the top right hand. And so I want to just directly look up that text form field widget. And then we're looking for the text form field class right here. All right, so if you want to, you could certainly take a quick glance at the documentation text here. You'll notice that it says in the first couple of paragraphs something about if we have a form widget, it makes it really easy to save, reset, or validate multiple fields at once. So that's what we're trying to do. We are trying to use a form widget to manage the email input and the password input as well. So as usual, we're going to go down to this thing's constructor, and we'll get a better idea of what we can pass to it. So here's our text form field and all the different properties that we can pass to the constructor. Now there's going to be a couple of ones that you and I are going to really care about. I'm going to point them out as I can kind of find them in here. So the first one that we're going to really care about is input decoration prop right here. So input decoration is how we're going to specify a label to be displayed above the actual input. So remember, as I mentioned earlier, when we show a text form field, it encapsulates not just the input itself, but also the label that is shown above it and any validation text that gets displayed underneath it as well. So by just showing a text form field, we get all three of these things for free automatically. In order to specify the label that we want to have shown above, we're going to use that decoration right here. So this name property of decoration. Let's add this on first and get a better idea of just how to add in a text input, or excuse me, a label above the text input. Okay, so back over here, we're going to start first with the email field. So I'm going to return a text form field. And for right now, the only named property that I want to pass in here is that decoration thing. So decoration is supposed to be of type input decoration. So let's look at the documentation on that very quickly. All right, so here's the input decoration class. This is what we use to customize the borders, labels, and all other stuff around text fields. So you can kind of think of input decoration class as modifying the way that these input fields appear on the screen of the device. If we go down a little bit, as usual, we'll look at our constructor right here. So a couple of the properties that you and I really care about are things like label text. So that's going to specify the label that gets shown above the actual input. And then there's also something on here called hint text as well. The hint text right here, you can kind of think of as being like a placeholder of sorts. So kind of some temporary value that will appear to be in the input to kind of guide the user and give them a better idea of what type of input they're supposed to add. So let's try creating a new input decoration and specifying the label text and the hint text as well. All right, so back over here, here's the decoration. I'm going to make a input decoration. Don't forget to get the comma at the end there. And then we're going to specify a label text first. So the label that I want to show on the screen, something like email. Yeah, we could probably do a little bit better than that. Let's do something like email address. And then as the hint text, and again, that's kind of like our placeholder, I'll enter something like you@example.com. So again, this is just going to guide our user and make it obvious that, oh yeah, I'm supposed to do like my email name at domain.com or wherever my email address might be hosted at. Okay, so let's save this and we're going to test it out in our simulator. Before we test it out, you'll notice that whenever we call password field right now and submit button, they are not currently returning any widget whatsoever. So if we ran this code as is, we would probably see an error message complaining that password field and submit button are not returning anything. So to make sure that we don't call those methods, I'm going to go back up to where we added them to this children property on the column, and I'm just going to very temporarily comment those two out. So as soon as we implement both those methods, we will uncomment them, but for right now, only email field has functionality tied to it. Okay, so now I will get my terminal and simulator back up. I'll do my hard refresh with Shift R. And awesome. All right, so here is our default material text field widget. So you'll notice at the top, we have our label text of email address. We get the line to indicate that, hey, this is some place where you can type. I can click in here, and when I do, you'll see that placeholder type text, or what's referred to as the hint text, appear. So it says you@example.com, and again, this is just intended to kind of guide our users and help them understand what they're supposed to enter in here. So now I can start to type in whatever my input might be. All right, so that made some progress. We got our input on the screen and we got a label on there as well. So let's take a quick pause and we'll come back in the next section. In the last section, we got our text field to appear on the screen right here, and we've got our label and the hint text displayed on there as well. Now there's one little odd thing that I want to point out about our current input. Notice how we are expecting a user to enter an email here. So presumably they need to enter in some text at example.com. However, the keyboard that we have right here, well, we can easily add in text, but if a user wants to add in that @ symbol, they have to click on the symbol indicator right here and then click on @. And that's kind of a pain in the rear for our users. You and I know that a user is going to have to enter in the @ symbol here, so we're really just making life more complicated for our users by forcing them to press the symbol button and then select the @ symbol. So to get around that, we can actually customize the way that the keyboard down here gets displayed to our user. I'm going to flip back over to the documentation for the TextFormField class. I'll then go down to the constructor. So here's our constructor, and I'm going to look for a property called, let's just do a search for it. There we go, keyboard type right here. So the keyboard type property allows us to customize how that keyboard appears at the bottom of the screen. And we can kind of customize the keyboard that gets shown to more easily assist users in entering, say, an email address. So I can look at the text input type right here. I'll click on that and look at its documentation. Then inside of here, I'm going to scroll on down to the very bottom and find the constants section. So these constants right here are constant keyboard types that specify exactly how the keyboard is displayed on the screen. You can pretty much read the text, and I think you'll very quickly get a good idea of what these are used for. So if we want to show a keyboard that optimizes the display for email addresses, well, we're going to use this email address constant right here. So essentially, all we really have to do here is find our text form field, and into the constructor, we're going to add in keyboard type. And for the keyboard type, I'm going to specify a text input type. And I'm going to reference that email address thing, like so. Now, notice how we are referencing a constant value on a class here. So we do not have to create an instance of the class first. We can just freely say, here's the class we're looking at, and I want to access this class property on the class. So just text input type dot email address. So if we now save this and refresh our emulator again, when we focus our input here any second, there we go, you'll notice that now our keyboard has changed slightly. So now right next to the space, we've got the @ symbol, which just makes it a little bit easier for our users to add in the @ symbol and then continuing to type in the rest of the email address without having to access that symbol menu. Okay, so just a little bit of an improvement, but it's something that makes our users' lives a lot better. So now that we've improved our keyboard type, let's continue customizing our text form field in the next section. In the last section, we customized our email field by specifying the keyboard type for it so that the user could more easily select that @ symbol. We're now going to move forward onto creating our password field. The password field is also going to be a text form field, but it's going to have some slightly different options passed to it. So to get started, I'm going to expand the password field method. And from there, we are going to return a text form field. Now, like I just mentioned, a lot of these options are going to be very similar for the password field. The first property we're going to add on is that decoration to make sure that we specify an appropriate label text and appropriate hint as well. So inside of the text form field, I'm going to add the named property of decoration, and I'm going to give it an input decoration. I'll give it a label text of, how about enter password? And then for hint text, we could just do something simple like password. Adding in a hint or a placeholder to a password field doesn't make a lot of sense because we can't really give our users a hint of what their password is per se, but we can at least add something in here to say like, yeah, this really is supposed to be your password. All right, so that's enough to get started with. I don't think that we need to add in a keyboard type because for a password, we don't really care about presenting that @ symbol quite so prominently. So no need to add a keyboard type on the text form field for the password field. Now to test this out, I'll scroll back up to my build method. I'll find the password field call that we had commented out, and I'm going to uncomment it like so. Then I will flip back over to my terminal. I'm going to refresh the application with Shift-R, and then I will expect to see a second input appear here on the screen. All right, so there it is. So we've now got email address and enter password. So I can select this thing and then enter in text. Now, as I'm starting to look at this, there's something a little bit awkward about it. Notice how on the first input up here, we have a label of email address, and the second one says enter password. Kind of inconsistent with the terminology we're using there. So just because I'm a little bit nitpicky, I think I am going to change the label text on the password field to be simply password. Now the label text and the hint text are the same, which is also not the best thing in the world, but hey, you know what, we don't need to worry that much, I guess. This is good enough for now. All right, now the other thing that you might be curious about here is that when I try to enter in some text for the password, it's all displayed with plain text. But it'd be really nice if we instead saw like those little security dots instead, so that other people can't look over our user's shoulder and plainly see the password of our user. So I would really like to make sure that this password input right here is regarded as a password input element. To add on that customization, we're going to again look at the documentation for the text form field. So back at my documentation, I'm going to find the text form field class. You can probably guess where we're going to go. I'm going to find my constructor. So on my constructor right here, we're going to look for a named property of obscure text right here. So obscure text is a Boolean. By default, it is false. If we pass in obscure text of true instead, then that input will show dots after user enters some text in. So on my password field right here, I'm going to enter in, outside of the input decoration, I'll enter in obscure text true, like so. So now if I save this and do a quick refresh again, I should now be able to select that password input, and then when I enter in text, the first character is displayed as plain text, and that's just a helper so that users understand what character they just pressed, but everything else inside there is represented with a single dot, which is definitely what you would expect for a password input. So this is how we turn a normal text input field into that kind of password appropriate one. Now, for the rest of this application, I am not going to use obscure text just because I want to have you see the text I'm entering in that password field. It's going to be a little bit relevant later on for you to be able to see the actual text I'm entering. So I'm going to remove this setting, but you are absolutely free to leave it on there and leave it in as true. One other thing you could do is just leave it as false, like so. Little bit, don't really have to because like I said, obscure text defaults to be false, but if you just want to remember how you can obscure the text more easily, you could definitely leave that note in there. But again, I'm going to remove it simply because I want you for this course to be able to see the text that's in there. Okay, so that's good for our password field. Let's take a quick break and we'll come back in the next section and put together our submit button at the bottom of the form. In the last section, we added in our password field method. So that is also displaying a text form field. We're now going to move on to our submit button method, which is supposed to show a form at the bottom of the screen. So as a quick reminder, to show a button, we're going to use a built-in Flutter widget called the raised button widget. Let's very quickly check out the documentation for this raised button and get a better idea of how it works. So back over on my Flutter documentation page, I'll do a quick search for raised button. And on the documentation, I bet you can guess what we're going to look up. Yep, that's right. We're going to look up the constructor. All right, so here's our constructor right here. So when we create a raised button, there's a tremendous number of properties that we can pass in to customize how the button behaves. Or maybe a better term here would be to say we're customizing how the button looks. So if you take a close look at all these different parameters, the raised button constructor is really all about customizing the styling on the button that gets displayed. And there's very little that customizes the text that shows inside the button or what happens when we press the button. Those do exist in here, but all the vast majority of options that we can customize are all about the display properties of the button itself. So you'll see things like customizing the padding or the elevation, which affects the shadowing behind the button, the color, whether or not it's disabled, all that other kind of good stuff. So to actually get some text to show up inside this button, you'll notice that there's not a distinct like text property. Instead, to show some text inside of raised button, we have to pass in a text widget to the child property. So this is another widget that accepts a child widget and displays that child inside itself. So I'm going to flip back over to my editor. I'm going to find my submit button method right here. And inside of it, I'm going to return a raised button. And inside of it, I'll specify a child that has the text submit, like so. Now, when I save the file, you'll notice that raised button has a little green warning underneath it. If I hover over that, it tells me very simply the parameter onPressed is required. So the raised button accepts a onPressed argument to it, or an onPressed parameter. That is supposed to be a callback function. And you'll notice here in the documentation, it is marked as a required parameter. So anytime we create a raised button, we have to pass in a callback function to this onPressed parameter right here, or we're going to get an error message when we try to run this thing. So back inside my code editor, I'm going to add on an onPressed parameter, and I'm going to assign to it an empty function like so. So at this point, we're not really doing anything with the button. I just want to get it to show up on the screen. So I'm going to save this, and then we'll flip back over to our terminal. Yep, we'll do our quick refresh here, quick test. So I'm going to save. And then inside my emulator, I should see a button. Oh, we forgot one step, or at least I did. We just added in some configuration for submit button, but we never actually uncommented its call up here inside of our build method. So up at the build method, I'm going to make sure I uncomment submit button, and then we'll do our refresh. All right, so there's the restart, and there's the button. Okay, well, hey, it's a button. You can tell it's got a little bit of shadowing underneath it, and that's where the term raised button comes from. The word raised means to indicate that this is kind of a button that pops out of the screen a little bit, thanks to the shadowing styling. However, the button itself is really smashed up against the password field, so I think we probably need to add in some margin or some padding to this thing on the top to get it to stand off of the password element. Let's take a quick pause right here. We'll come back to the next section and add that little bit of spacing in. So I'll see you in just a minute. In the last section, we got our raised button widget to show up on the screen, but it's sandwiched directly against the password input. In addition, the button itself is gray, which is just a little bit boring. So in this section, we're going to very quickly fix the color. We'll then take the break and we'll put in a little bit of spacing between the password element and the button itself. The reason we're going to take a break first is that the process of adding in that spacing is going to be just a little bit involved, and so I want to make sure that we have a lot of time to address it. So very quickly, let's make sure that we change the color of the button. To do so, I'm going to first very quickly open up my raised button class documentation. And then on my constructor, you'll notice that it has a name parameter of color. So we can simply pass in a color property to this thing, and it will change the color of the button. So back at my raised button element inside the submit button method, I'm going to add on a color, and I can specify one of the constant colors on the colors class. So I'll say colors dot, and then I'll just make this thing blue, like so. If you're using VS Code, you can actually hover over that blue property right there, and you'll get a nice little preview of what colors.blue looks like, which is a nice little thing. All right, so quick test. I'll save this file. I'll do my refresh, and our button is blue. Okay, simple enough. So let's take a quick pause right here. Again, we're going to separate this into two sections because adding in the spacing is just a little bit complicated. So quick break, come back to the next section, and add that spacing in. We just updated the color of our button widget at the bottom to be a nice blue. We're now going to address the fact that we have absolutely no spacing between our password field and the actual submit button. Now to actually add in the spacing here is going to involve just very few lines of code, but it's a kind of a question of where we add this code that makes the spacing here a little bit more of a complicated thing than it might seem at first glance. So let me first say that to add in spacing anywhere inside of our application, we can very easily use that container widget, as we did up here inside of our build method. We saw this in the last application we worked on as well. We could add in a container that has a margin, and then we specify the sides on which we want to apply this margin to through the edge insets class. So adding in spacing, not a problem. Again, it's the issue of where we add the spacing. So let me show you one possible way of doing this, and then I'll tell you exactly why it might not be the best approach of adding in some spacing. So we want to make sure that the password has a little bit of margin directly underneath it to offset the button that we see. So I'm going to go and find the password field element. So here's the password field method. We've got the text form field inside of it. I'm going to create a new container widget, and I'm going to wrap the text form field with that container. So to do this refactor, I'm going to first put the container together right above, and then I'll cut and paste the text form field into it. That's the easiest way of kind of writing this stuff out. So I'm going to return a container that has some margin. I'll give it an edge insets, and I only want to have some margin on the very bottom of this field. So I'm going to add in only with a bottom named property, and I'll give it like 25 pixels or so of spacing. Then I'll add on the child property, and that's where we're going to add in our text form field. So I'm going to select just the text form field, so I'm not selecting the return keyword, and I am not selecting the semicolon at the end. I'm going to cut all that, and I'll paste it in for the child right here. So there's the child. I'll add in a comma at the closing parenthesis for the text form field. I'll remove the return statement at the bottom, and then I'll save that. Okay, so what we have right here, it definitely works. And let me prove it to you. I'll very quickly go and do the refresh. And we'll see that margin kind of applied to the bottom of the password field, and hey, we're looking pretty good. So let me tell you now why that approach is maybe not the best. If I go up to my column widget right here, we're currently placing the email field, then the password, then the submit button. So let's imagine for a second that we were not making a form to log in. Maybe instead we were making a form for like anything else, where we might want to reorder these fields in different ways for, I don't know, any given reason. So if for some reason I wanted to put my password field above the email field, let's do that right now. So I'll put the spacing in there. Now the password field shows up first, then the email field. So think about what's going to happen now. If I go and refresh at my terminal, we're now going to see a ton of spacing underneath the password, and then the email field is directly up against the button. And so we are in the exact same situation that we were before. So if we wanted to be able to quickly manipulate the order of the fields that are showed inside of our form, we would have to be doing a pretty big refactor every time. Every time I would have to go down to my password field, I would have to extract this container, and then instead add it to the email field directly. If I instead added the container to the button down here, then I'm kind of in the same order again, or I have the same problem as before. You know, usually, yeah, we're going to put our button at the very bottom of any list of a form elements. But let's say that for some crazy reason, I wanted to show the form or the button here first. And now we have the same problem if we had applied the container to that button. So the key thing here to understand is that if we take any one of these methods and we wrap them with that container, it's going to make it a real pain in the rear to refactor in the future. So there is a better way of adding in the spacing and making sure that we write much more maintainable and reusable code that doesn't have to be quite so intensely refactored every single time that we want to change the order of our fields. So let me show you how we're going to do that. First thing I'm going to do is restore the order of my fields here. So I'll put the submit button at the bottom, and I'll put the email field first. I'm then going to go back to my password field method, and I'm going to remove that container that we just created. So here's my container. I'm going to delete everything up to the text form field. I'll take off the extra parenthesis in there, and then if I save it, I'm back to how I was before. And so now if I refresh, I should still see my working application in here, but with no spacing. Okay, so we're back to how we were before. So let me show you the better approach that we could take. I'm going to go up to my column widget right here. Now inside the column widget, we're listing out all of our children. And as we've said, clearly adding in any margin directly to any one of these widgets is not a good approach. So instead, I'm going to add in an extra entry in this widget list right here. And in this extra record, I'm going to directly create a container that has some margin assigned to it. So I'll do an edge insets only on top 25 pixels. And I'm not going to add a child. So we now have a container element that solely applies some margin to our layout and does absolutely nothing else. This doesn't try to show any child inside of it. It just tries to manipulate the spacing inside of our layout. So now I think you can very easily see the benefit in this approach. I could very easily reorder my fields inside of here into any order that I want, and it really doesn't matter what order I end up with. I could put the email field at the bottom, the password field above that, and the submit button above that, and I've got this separate container element here that I could easily move around or cut and paste as I please to add margin anywhere that I want. So I could do something like that right there, and now I've got 25 pixels between everything that is displayed inside this column. All right, so let's very quickly restore to the order that we probably want. So I want my email field first and submit at the bottom. All right, so I'll save this and we'll do a quick test. And now we have the email, password, that 25 pixels of spacing thanks to the container without a child, and then our button. All right, so like I said, this is a way more maintainable way of kind of adding in spacing between our elements. Much preferable to add in these kind of simple containers rather than always trying to wrap some element with a container and applying margin to that. Now, last thing I want to mention here, using a container in this fashion, well, as you might guess, only really works when we're using a layout widget like a column. So if rather than a column, we were trying to display something like directly in the form, which accepts a single child, well, in that case, then of course we have to use a container and provide it a child of whatever widget we want to show inside of it. So this methodology that you see right here is really only applicable when we're trying to show a distinct list of widgets on the screen. But nonetheless, in that case, very handy approach. Okay, so long last, we got our spacing in there. Let's take a break and we'll continue in the next section. The layout of our application is pretty well coming together at this point. However, if I enter in some clearly invalid email and then click on the submit button, I'm presenting no feedback to my user to let them know that this email is not valid. So in this section, we're going to start turning to the actual submission of this form and figuring out how we can validate the values inside these inputs and then eventually access the values that the user entered. So to get started, we're going to take a look at a quick diagram that's going to lay out this process. Okay, so here's the steps. Everything is going to start up here with step number 1, the user pressing that submit button. It's only when a user presses the button that we're going to start the validation process. When a user presses the button, the onPressed callback that we added to our raised button widget is going to be invoked. So if you recall, down at the bottom, we have our submit button right here. Here's the raised button widget, and on the raised button, we added the onPressed callback. So anytime a user presses the button, this function right here is going to be invoked. So this function is going to be the perfect location for you and I to add some location to attempt to validate the form and then eventually access the values inside of it. So once we add that callback in, or I guess we already did, once that callback is invoked, we're going to attempt to access the form widget. And we're going to tell that form widget, hey, you need to validate all of your TextFormField children. So quick reminder, here's our widget hierarchy. Inside of our hierarchy of the login screen, we created that form widget, and we just very quickly brushed over it. So inside of our build method right here, here's the build method, here's where we created a form widget instance. So we need to get direct access to that form. And we need to tell it, hey, you need to find all of your TextFormField children, and you need to tell them that they need to validate themselves and make sure that they have appropriate inputs. Now behind the scenes, anytime that we place a form widget with some text form fields as a child to it, the form gets this kind of behind the scenes direct connection to those child text form field widgets. So this form right here knows about the existence of this text form field, and it knows about the existence of this text form field. That's a behind the scenes connection that is made for us automatically. And it doesn't matter that there's the column widget in between. The form just knows that these text form fields exist as children. So all we have to do is get access to the form widget itself and tell it to go find its children and attempt to validate them. Then, if all those different fields are valid, we're going to then attempt to actually extract the values that a user entered into them. And then once we have those values, well, that's the last step here, and we'll figure out what we'll do when we get there. We definitely have a lot of stuff to do before that. So in terms of difficulty or the actual implementation of all these steps, I think you'll agree with me that step number 1 and 2 right here are pretty straightforward. Like, we really know how to add that callback in. We already did it right here. So it's really step 3 where things get interesting. On step number 3, we need to somehow get a reference to the form widget. And we need to somehow run a method on it that tells it to try to find its children and validate them. So that's going to be the hard part here. Let's take a quick pause right now. We'll come back to the next section and talk about how we're going to achieve step number 3. In the last section, we started talking about how we're going to somehow get our form to validate itself anytime the user presses the submit button. So we're down here on step number 3, where we need to first somehow get access to our form widget. And then after we get access to it, we need to tell it to validate all the text form fields that are associated with it. So we're going to first focus on part number 1 of this. We need to somehow access the form widget. This is something that we have not yet done in any of the Flutter code that we've written so far. As a quick reminder, every time that we've been looking at all these different pieces of documentation around all these different widgets, we've always been focused solely on the constructor methods. So we know how to create these widgets, but once they've been created, we don't actually know how to call any methods or call or reference any properties that are associated with them. In other words, we might be able to create a text form field, but if you then go down to the property section here, or the method section, you'll see that there's a bunch of methods associated with these widgets. And we have not yet seen how we can somehow reference a widget that we have created and then call a method that is associated with it. So that's what we need to do. We need to somehow get a reference or a handle to a widget that we create inside one of our build methods. Now you might be thinking that this is something really easy. You might be thinking that, okay, Stephen, yeah, no big deal. Let's just go find our build method. And you might guess, this is not correct. This is not how we're going to do it. But you might be thinking, yeah, we'll just say, I don't know, make a new variable called form reference. We'll make a new form, assign it to form reference, and then we can just go ahead and insert that somewhere into our widget structure here. Maybe right here, I want to put my form reference like so. And then later on, we can call form reference dot validate children, or whatever method we want to call on the form itself. So unfortunately, this is not how we do it. We do not create a widget and then try to save a reference to it. The system for getting a reference to a widget is a little bit more complicated. All right, so I'm going to undo all that. And we're going to take a look at a diagram that's going to give you a better idea of how we're going to get a reference to a widget and then call methods or reference properties associated with it later on. Okay, so quick diagram. Here we go. All right, so this is our widget hierarchy. We've got our login screen right here. Now I'm going to zoom in on that section. Okay, so on our login screen, we're going to add a new instance variable. That instance variable is going to be a type of GlobalKey. A GlobalKey variable, or a variable with type GlobalKey, gives us a reference to a unique element or a unique widget that has been created inside of our widget structure. So you and I are going to create this GlobalKey. Then when we create our form widget, we're going to pass that GlobalKey to the form that you and I create. Then at some point in the future, after our login screen has been rendered on the screen of our device, we can then get a reference to the form that was created by making use of this global key. So the global key variable is how we get a reference to a particular element that has been rendered to the screen of our device. Now that's the easy way of explaining this, okay? Basically, we want to use a global key. That's the takeaway. However, in this particular case, with us using a form widget right here, we're making a form widget and we want to reference that form and tell it to validate all the fields. Unfortunately, because we're using a form, our situation is going to be just a little bit more complicated. So let's take a quick pause right here. We're going to come back to the next section and we're going to expand on this idea of global key a little bit. And I'm going to tell you exactly why using a form here with a global key is just a tiny bit more complicated. But for right now, all you need to understand is that to reference a widget that has been rendered to the screen of the device, we create a global key. That's all you need to know for right now. So quick pause, and we'll come back in the next section. In the last section, we started talking about how we can reference a widget that has been created by creating a global key and kind of pointing that global key at the widget that we are making. So this global key thing is how we kind of maintain a reference to a widget that's been created. So I think that part we kind of understand. I've repeated that phrase like 4 times now in the last 2 minutes. So we get that idea. So now we're going to pivot just a little bit and we're going to talk about why using a global key with specifically a form is going to be just a little bit complicated. Okay, so we're going to pivot and we're going to talk about the form for just a minute, and then we're going to bring back in this idea of the global key. All right, so here we go. So now we're talking about the form itself. So whenever a user sees this form on the screen, and specifically like our form widget and the text field widgets that are displayed inside of it, we get this kind of flow of interaction that's displayed here on the right-hand side. So a user focuses this input, they then type some data in, and then this series of action occurs. So first off, the user types in some data. That clearly is changing some data inside of our application. It is changing the value that is associated with this input right here. And it appears that anytime that data changes, our form widget, or perhaps it'd be better to say the TextFormField, is clearly re-rendering itself on the screen with that new data. The new data being the text that the user typed in here. In other words, when I select this input right here, and I start typing stuff in, I see that data appear within that widget right there. So clearly, whenever I change the data of this little widget, it is re-rendering this widget on the screen of my device. So now here's my question to you. Does that process remind you of anything that we've spoken about so far? So we're clearly saying here that if we change data, it re-renders our widget on the screen of our device. So again, does that remind you of anything that we've been discussing? Well, it might remind you of how a stateful widget behaves. Remember, we use a stateful widget when we want to have some data that's going to change over time, and anytime that data changes, we want to re-render the widget on the screen of the device. So here is why our global key stuff right here is going to be a little bit complicated with our form widget. It's complicated because our form widget right here is actually a stateful widget. The form right here, it's actually a stateful widget. It's not stateless, it's stateful. And so our widget hierarchy actually looks like this. This is what's actually going on behind the scenes. Whenever we create an instance of form, not only are we getting the kind of core form widget that renders something on the screen of the device, but it's also behind the scenes creating a form state instance. The same kind of class that is created by our login screen state right here. And so I'm kind of mirroring that in the diagram. Remember, when we create a stateful widget, we get the kind of widget that represents our widget on the screen of the device, or the class instance that represents our stuff on the screen of the device. This widget right here, this class, gets created and thrown away every time our application is re-rendered. But our login screen state over here is persisted to hold all the values that we've assigned to it and changed over time. And so the same thing is occurring with our form that we've created. We've got the core form widget over here that is responsible for showing information on the screen of the device. This form gets created and thrown away every time our application re-renders. But the actual values that are stored within our form are persisted within this form state object. So that's why our situation is a little bit more complicated when it comes to that global key. We don't want to associate the global key with the form, the information that you and I care about, like the status of all those input fields and whether or not they are valid, is actually stored with the form state, not the form. So in summary, what you and I really want to do here, we want to create a global key, and we want to associate that global key with the form state, not the original form. Now in practice, when we create this global key and pass it off to the form, we're going to write code that very clearly passes off that global key to the form. Like that's what we're going to write. We're going to create the global key and we're going to pass it off to this form instance right here. But I'm just telling you all this to let you know what is really going on behind the scenes. When we create that global key and we pass it off to the form, in the end, the global key is actually going to reference this form state that is created for us. Now that might not seem like it's super relevant right now, but as soon as we create the global key and associate with the form, you'll see why it's relevant right away. Okay, so all this stuff, I know this is pretty heavy duty stuff. It's not the easiest stuff in the world, but let's take a pause right here. We're going to come back to the next section. We're going to make that global key and we're going to associate it with our form, and then we'll be able to reference the form and call different methods that are on it. So quick break and I'll see you in just a minute. In the last section, we spoke about how we need to create a global key and somehow reference it or get it to reference our form state that is created anytime we create a form widget. Again, I know this stuff is kind of heavy duty, kind of complicated, but as soon as we start writing some code, I think you'll start to get an idea of what's going on. So let's write some code. I'm going to begin by flipping back over to my code editor, and I'm going to find my login screen state class. So inside of here, I'm going to create a new instance variable that's going to store that global key. So I'm going to make a final variable, which remembers just means I cannot reassign this variable. I'm going to call it FormKey because it's referencing the form. And to it, I'm going to assign GlobalKey. And then this thing uses that same generic syntax that we use for state up here. Remember, these generic open, closing little brackets are our way to kind of create a constructor or a class that accepts a type almost like a function. So we put a type inside of here, and that customizes how all the functions inside of it behave, or at least what different types they expect. So to the global key, we do not want to reference the form class. We want to reference a class called formState. So for the type here, I'm going to put in formState like so. And then I'm going to put my set of parentheses to indicate that I want to create an instance of this global key thing. Okay, so this right here is just about the only place we're going to see this form state thing come into play. That's why I had to tell you about the existence of this form state, because at some point we had to like write out form state right here. If we just wrote form state, you probably would have been like, Steven, why are we writing form state and not just form? Okay, so this creates the key. Now step 2 is to take this key and associate it with the form widget that we are creating. So on my form widget, as an additional named property, I'm going to pass in key, and key is going to be the FormKey instance variable that we just created. So I'm going to say FormKey like so. And that's pretty much it. In the last section, we created this FormKey instance variable. We assigned it an instance of a global key that is kind of conformed to expect to reference a form state instance. And then we pass that key off to our form that we created right here. So now our form is going to reference the form state instance that is created when our login screen state appears on the screen of our device. So now that we have a direct reference to our form state instance, we can go and look up the documentation for form state, like the actual form state class, and just see how we can actually interact with this form state that has been created. Let's take a look at the documentation. I think you'll see what I'm getting at. Okay, so I'm going to go back over to my Flutter documentation. I'm going to do a search for form state. Here's the form state class. And now that we have a direct reference to the instance of form state that is created when we make our form, we can look at all the different properties that are associated with this thing and all the different methods that are associated with it as well. So whereas before, you and I could really only get access to the different constructors that are associated with all these different widgets, we now have the ability to reference all these properties and call all these methods thanks to the global key that we set up right here. So again, the global key gives us the ability to reference a very specific widget, and reference properties and call methods that are associated with that widget. So in the case of our form state class, we can look at the different methods that are associated with this thing. You'll notice that one method is called reset. And if we call reset, then it's going to attempt to reset every form field that is a descendant of that form. So if we call reset on our form state class, I think that it should probably reset these two inputs right here. I think that even though that's not what our submit button is supposed to do, that might be a good test just to make sure that this stuff is working the way we expect. So I'm going to go to my callback on the submit button. So here's the submit button. Here's where we create the raised button widget. And here's the onPressed callback. So on this thing right here, whenever this thing gets pressed, I'm going to attempt to reference the form state instance and call the reset method on it. So to do so, I'm going to reference first the FormKey, which is going to give us a reference to the form state instance that is created to kind of back up or represent our form on the screen. So we just referenced the GlobalKey by writing out FormKey, and then to actually get a handle on the form state instance right here, we'd write out .current state. So if you now hover over current state, you'll see that it returns to us the form state instance or something of type form state. So FormKey.current state, this thing right here is our form state instance. So on this, I can call reset, and now anytime a user presses this button, it should attempt to reset every field within our form. So to test this out, I will do a full refresh with a Shift-R. I will wait for the reload. Okay, I'll enter in some random email, some random password, and now when I click on the submit button, I see that both my inputs got completely zeroed out, or essentially reset back to their default initial state, where they have no value associated with them whatsoever. All right, so that's pretty much it. That's how we get a handle on some particular widget that has been created inside of our application and call a method associated with it or reference a property. We use this GlobalKey thing right here. We save the key, and then we pass that key off to whatever element or whatever widget we want to get our reference to. So now that we have the ability to get a reference to our form state, we can now go back to this diagram. So we now have access to our form state. Now we can use that reference to tell it to validate all the text form fields that are rendered inside the form. So let's take a quick break and we'll tackle that in the next section. In the last section, we managed to use our FormKey right here to get a reference to the form state instance that belongs to this form. Once we had that reference to the form state, we then called the reset method on the form state, and we very clearly saw that that reset every one of the inputs within our form. So if we reference back to our diagram that we were looking at a little bit ago, over here, we've clearly accomplished part number one of this. We have direct access to the form state instance that represents our form on the screen. So now we're going to move on to part two of this, which is to tell it to validate all the text form fields that are nested underneath it. To do so, let's first take a look at some documentation and get a better sense of how we're going to use the form state to tell it to validate all the text form fields that are inside. Okay, so I've got my form state documentation up. I'm going to go down to my method section. So in the last section we called reset, there it is right there. So we're looking at the same section. And right underneath that, you'll notice that there's another method called validate. So if we call validate, that's going to apparently validate every form field that is nested within this form. And then if they are all valid, if all those form fields are valid, then the overall validate call that we're going to make is going to return true. Otherwise, it will return false to indicate that one of our inputs has some invalid input inside of it. Now, when you look at this method right here and the description for validate, this is a function that is tied to our form state class. You'll notice that the documentation doesn't say anything at all about how this validation is actually done. In other words, how are we going to make sure that the text form field that represents our password actually is a password? Like, we need to make sure that whatever gets entered into this field right here specifically looks like a password, and so maybe it has to have a certain number of characters. And likewise, we need to make sure that when this validation step occurs, this text form field that represents the email has to look like an email. So it has to have like, an @ character or @ symbol inside of it or something like that. So the documentation here is kind of lacking in that regard. The documentation is not telling you how you set a validation rule up. And in fact, in my opinion, all the documentation here not super clear on how you set up this validation stuff. So rather than trying to reference any documentation, I'm going to show you a diagram that's going to make this entire validation flow a little bit more obvious. Okay, here we go. All right, so here's what happens. Right now, we're inside of our login screen, or more precisely, the login screen state. We've created our global key, which represents or kind of references the form state object. And as we just saw, the form state has a method tied to it called validate. So that's the documentation we were just looking at. That's the validate function right here. So when we call validate, here's what happens. The validate function is going to look at all of the children of the form widget. And it's going to find every single instance underneath the form of a text form field. And so the validate function is going to automatically find this text form field and this text form field. Then on both of those text form field instances, the validate function right here is going to call a function that you and I can optionally pass into the constructor of the text form field called validator. The validator function right here is what is actually responsible for looking at the value that has been entered into the text form field and saying whether or not it is valid. Okay, so this validator part right here might seem a little bit confusing, so let's go make one quick change inside of our code editor and you'll see where this validator thing comes into play. So I'm going to go back to my code editor. I'm going to find my email field. Here's the text form field, and as an additional property to the constructor, I'm going to pass in a function called validator, or a property called validator a function to the validator property. There we go. So now this function right here is going to be automatically called anytime we call the validate function on form state. So now inside that validator function, we're going to have the opportunity to inspect the value that was entered into our text form field. And if that value is valid and we like it, we're going to return nothing. Otherwise, we will return a string that represents the error message that we want to show to the user. So essentially on this validator function, we're going to return null if valid, otherwise string with the error message if invalid. Okay, so hopefully now that makes a little bit more sense. So when we call validate on the form state instance, validate is going to find all of the nested text form fields. It's going to call the validator function on each one. It's going to collect all those things together, all the responses or all the return values from these different validator functions, and it's going to say, hey, are any of you not null? Like, did any of you have an issue? And if there is an issue, then the validate function back up here that belongs to the form state instance is going to say, oh, sorry, no, that form is not valid. Like, one of these fields is wrong, and the user is going to have to go fix it. All right, so that's the behind the scenes look at what is going on with this validate stuff. So let's take a quick pause here. We're going to come back to the next section, and we're going to write out our validator function for both our email field and our password field. So quick break, and I'll see you in just a minute. In the last section, we spoke about how calling the validate function on the form state object finds all the different text form fields and invokes the validator property that has been assigned to each one of those text form fields. So in this section, we're going to define our validator function on both our email field and the password field as well. So when the validator function is called, it receives as the first argument the current value of the text form field. So we can receive that as an argument to this function as simply something like, I don't know, value. And then since this is a text form field, that argument that comes in here is always going to be a string. And so optionally we can mark it as a string. Otherwise, if you hover over it, it's going to say, yeah, you're going to receive a string here. And what the heck, I'll just mark it as a string for fun. So now inside the validator function, we need to look at the value of this thing. And if it's valid, and if it looks essentially like an email address that we're happy with, we're going to return nothing. or return null. Otherwise, we're going to return a string that represents the error message, or something to tell the user what is wrong with the value that they just entered. So for you and me, just to keep life really straightforward, really simple, you and I are going to say that an email address is valid if it contains an @ symbol. So if someone enters something like that, for the sake of this application, this is a valid email for us. Okay, we're just going to check to see if there's an @ symbol in there. If it has it, great, that's a valid email and we're happy with it. So inside of here, we're going to say if value.contains @, and then specifically we want to find the case in which the string does not contain an @ symbol. So I'm going to put an exclamation right before it to flip the value. So now we're saying if the current value does not contain an @, then we consider this thing to be invalid, and we need to return a string that will tell the user what's wrong here. So if that's the case, I'm going to return a string that says, please enter a valid email, like so. Now technically, we do not need to actually put in a return null case. If we don't return anything inside of here, then by default, null is returned. So we can really just leave this as is. Or if you want to be really explicit, you can add on a return null at the bottom. It's totally up to you, but I'm going to leave it off. Okay, so that's our validator for the email address. I am going to clean up the comment here. And now we're going to go down to our password as well and add in a validator for that text form field too. So on my password field, I'm going to find my text form field. I'm going to pass in a validator that's going to be called with current value of the field, and we need to look at this value and decide whether or not the user has entered a valid password. And so again, we're going to set up an arbitrary requirement here. We're going to say that a password is valid if it has at least 4 characters. So we're going to say if password.length is less than 4, or excuse me, not password, value.length. So if there are less than 4 characters in there, then we're going to assume this is not a valid password, and we will return a string that says password must be at least 4 characters. Like so. Oops, forgot a comma. Let's fix that. There we go. Okay, so we've now defined our validator functions on both of our text form fields, which means we can now go back to our form state object and call the validate method on it. So down inside of my submit button on pressed handler, whenever a user presses this thing, rather than attempting to reset the entire form, I'm going to instead call validate. And then to figure out whether or not this thing is actually working, I'm going to put that inside of a print statement. So if our form is valid now, we should see true printed out at the terminal. Otherwise, if the form is not valid, we should see false printed out instead. All right, so I'm going to save this. We're going to do our refresh, and we'll test this out in the emulator. All right, so moment of truth. So first off, as everything stands right now, form is not valid because our email does not have a @ character in it, and our password field does not have 4 characters. So if I click on submit, I should see something that indicates, hey, form is not valid and it cannot be submitted. So if I click on submit, I see in my terminal false printed, which means the form is not valid. And I also see those 2 strings that we added inside of those validators appear on here as well to indicate to our user, hey, something's wrong with the form and you need to fix it up. So now if I enter in what we consider to be a valid email, which is anything that contains the @ symbol, and then a password of 4 characters or more, and then click submit again, our form is now valid. And we see true reflected down here to say, yep, form's valid and you're good to go. And then of course, if I revert back to an invalid state where I've got just like 1-letter password, it tells me, hey, not valid anymore, you need at least 4 characters. Okay, so that's it. That's form validation. Again, key thing to remember here, when we want to access our form, we have to create that global key. It's going to be tied to our form state object. And then on the form state object, we've got this validate function. When we call validate, it's going to automatically find all the text form fields that are nested inside of our form. and attempt to call the validator function associated with each one. All right, so we're not quite done yet. We have successfully validated those inputs, but we have not yet had the ability to somehow get the actual value out of them. Yes, we are passing the value to the validator function, but that doesn't quite seem right. So now that we have the ability to validate this thing, I now want to make sure that we also have the ability to retrieve the values that the user entered and, I don't know, do something with them. Say, hey, you're now signed in, or whatever else. So let's take a quick break and we'll finish up with that in the next section. In the last section, we were able to trigger some validation on our form state object anytime a user pressed the submit button. Now that we are actually pulling off this validation, we need to make sure that once our form is valid, we actually have the ability to extract the values that a user has entered into these two inputs. So for example, if I enter in an email and then click on submit, okay, well, it's great that I validated this, but now I need to actually reach into this field and get the value out of there so I can submit it to a server or, I don't know, print it out, do whatever I want to do with the actual value. So let's take a look at the documentation again and get a better idea of how we can pull a value out of a field. Okay, so I'm going to again look at my form state class. So down here under the method section, I'm going to find my save method right here. So the save method is what we're going to use to attempt to look at every different field that is nested within this form and somehow pull a value out of it. Now the downside to this save method is that it has the same issue that the validate function does and kind of a lack of documentation. So it says that it saves every form field. Okay, what's that mean? What does it mean to save a form field? Well, let's take a look at a diagram. It's going to give you a better idea of what the save method does for us. Okay, so very similar diagram to what we had before. We have our form state. We were calling previously the validate function, and that found all the different text form fields that were nested underneath this form. So now we're saying that we've got this save thing. So anytime we call this save method, a very similar process is going to occur as validate. So when we call save, the form state is going to find every text form field that is nested underneath this form. So it's going to find that one, and it's going to find that one. And I'm going to change the color on these just to make it a little bit more visible. And then on each of these text form fields, the form state object is going to look and see if we have passed in a named property to the constructor of the text form field called onSaved. OnSaved is going to be a function that gets invoked with the current value of the text form field. So just about identical to how the validator worked as well. When we call save, find the text form fields, find the onSaved functions tied to each one, and invoke them with the current value of the input. So inside of that function is where we're going to have the opportunity to take the current value of the form field and submit it or do something useful with it essentially. Okay, so let's flip back over to our editor, and we're going to first begin by adding on these onSaved properties to both of our text form fields. Okay, so I'm going to first find my email field. And underneath my validator, I'm going to add on onSaved. So this is going to be a function that gets called with the current value of this field. It's going to be of type string because, again, it is a text field, and we'll refer to that argument as simply value. And then inside of here, for right now, we'll just print out that value and make sure that we're actually getting the email out of the field. Then I'm going to scroll down to my password field, and I'll do the same exact thing. So underneath the validator name property, I'll add in onSaved. I'll assign a function to it that's going to be called with a string that we will refer to as value. And I'll just print out value. Oop, forgot my comma on that one. Don't forget the comma after the onSave function. All right, so now the last thing we have to do is actually call save on our form state object. So down again inside of submit button, here's our onPressed function. Right now, we're just trying to validate the form, but now we want to validate the form, and if it is valid, then we want to attempt to call save on the form state. So in order to only call save if the form is valid, I'm going to first remove the print statement that we've got in here. I'm going to remove the semicolon at the end of the line, and then I'm going to wrap the validate call inside of a if statement, like so. So now think about what's going to happen here. Whenever a user presses on the button, onPressed gets invoked. We're going to look at every field inside this form, and we're going to attempt to validate it. If every form is valid, then the validate function will return true. So we will enter into the body of this if statement. But if any value or any field is invalid, then the validate function is going to return false, and we're going to skip over the if statement entirely. So now inside of here is going to be the perfect location for you and I to call save on the form state object and attempt to print out the password and the email. So now inside of our if statement, we'll do FormKey.currentState. So again, this is our reference to our form state object, and I'll call save on it. All right, time to test. So let's do this. I'm going to do a full refresh. Wait just a minute for that to go, and now I'm going to enter in some email that is valid, so it needs to have the @ symbol, and then I'll put in at least 4 characters here, and I'll click on submit. Now at present, the form is valid, so I successfully see my email and password printed out inside the terminal. But if I make either of these fields invalid, so now password only has 1 character, so that's not valid, and I click submit again, I don't see a console log over here because the form is valid and it should not be saved. If I again add in enough characters and click on submit again, I'll see the console log over here again. Or excuse me, the print statement, not console log. All right, so we've got our values through the use of these on-saved things. Now it's definitely great that we're printing out the values, but we still don't really have the ability to kind of take both the email and the password and kind of combine them together and like send them off to some remote API or something like that. So we still have a tiny bit of work to do. Let's take a quick pause and finish this thing up in the next section. In the last section, we were able to take our form state object, call the save method on it. When we did so, save method found all of our nested text form fields and called the onSaved function that was tied to each one. So now that we have successfully implemented all this stuff, and we are successfully printing out the actual values associated with each field, we need to make sure that we get both these values into some common location inside of this widget. In other words, it's great that we have access to the value inside of onSaved, but chances are that if we get to like right here, we want to take both, like both is the important part there, email and password, and post them to some API or do something like that. So essentially, I want to get my email and password on like this line of code right here. So to do so, we're going to add some instance variables to our login screen widget. So up here at the top, underneath my form key, I'm going to add on an instance variable of type string that I'll call email, and I'll default that to be an empty string. And I'll do the same thing for another instance variable called password. So now, anytime that my onSaved method gets called on either field, I'm going to take the value that's passed in here, and I'm going to assign that value to the appropriate instance variable. So for the email field, I'm going to assign to the email instance variable I just created that value. So value is the value coming out of the text field itself. I'm going to assign it to my instance variable of email. And I'll do the same thing for my password field as well. So inside of onSave down here, I'll say password is value. So now, down inside of submit button, here's my onPressed callback. We do the validation, we call save right here. When we call this line of code, that goes up and executes those onSaved callbacks and updates the value of our instance variables. So now on the very next line of code right here, I can assume that the instance variables email and password have been updated successfully. So right here, I could print something like time to post, and I'll do some string interpolation here of email and password to my API. Or essentially consume the email and password in whatever fashion your application needs. So last thing to test, I will refresh my simulator again. Doing the restart. Come on, there we go. All right, so I'll enter in a valid email. I'll enter in my password of at least 4 characters, and I'll click submit, and I see time to post that email and that password to my API. So that's pretty much it. So now right here, whatever you want to do with those form inputs, you have, by this time right here, you have successfully validated the form and said, yep, everything looks great, we're ready to go. And so all you have to do from here on out, after validating, is call save to retrieve those values and then consume the values as you wish. So that's pretty much it. That is our login screen using stateful widgets. Now, before we move on, quick reminder, we're not quite done yet with all this login stuff. We still want to take care of learning how to do all this form stuff that we just went over by using that block pattern as well. But before we do that refactor, there's one other really quick item that I want to mention. So let's take a brief pause right here. We're going to come back to the next section and we're going to do one little refactor to our login screen state method right here. That's going to be a really useful refactor. So quick break and I'll see you in just a minute. Our login form is looking pretty great, but there's just one last little thing that I want to fix up inside of our code base. So at present, we've got our login screen state, and inside of here, we've got that method email field, where we produce a new text form field. The text form field has that validator function, which receives some given value. We inspect that value, and then we return an error message if the value doesn't conform to some given constraint. Now at present, our application has just one form inside of it. And so writing the validator directly inside of here, totally fine. However, I bet you could easily imagine that if we had a more complicated application, we might have many different forms. And maybe all these forms would be something like this login form. Maybe we would have a sign up form. Maybe we would have a forgot password form. Essentially a lot of different forms that would probably try to have a user enter in their email address. And so if we have an application with many different email inputs inside of it, we might want to try to reuse this validator function right here inside of many different inputs that we put together. So even though it's totally fine for the application we just put together to write the validator directly right here, I think that we should figure out a way to make this function a little bit more reusable to handle the case in which we might have other inputs that we want to validate. So to make this function right here a little bit more reusable, we're going to use a feature of Dart called mixins. So let's talk about what a mixin is and how it's going to help us reuse this validator function. Okay, so on the left-hand side, we've got our login screen state class. And as you well know, we have methods tied to it like build, email field, password field, and submit button. You and I are going to make a second class inside of a different file, and we're going to call that validation mixin. So this is the name of the class right here. Then inside that class, we're going to add two methods, one called validate email and one called validate password. And as you might guess, those functions are going to be email, validate email right here. And the second function, this right here, will be validate password. We're going to set this thing up as a mixin. The idea with a mixin is that we can link this mixin to another class, so I can essentially form a link between these two classes like so. When I set this link up, all the methods that are defined inside of validation mixin, you can imagine are copy-pasted from this class over to the target class. So we can kind of imagine that we are copy-pasting the validate email and validate password methods over to our login screen state. So we're going to define all of our validations inside of one single mixin, and then if we have many different form inputs inside of our application, we can just reuse this class again and again as a mixin to get these methods copy-pasted over. So if we later on had like a second screen of something like forgot password, where we would definitely want to have some email input over here as well, so a user could retrieve their password, we could form a link from validation mixin over to forgot password screen, and very similarly that would copy paste these validate email and validate password functions over to that other class as well. So mixins are a great way of reusing functions throughout a single application. Anytime you find yourself rewriting the same function over and over, great candidate for a mixin. So let's take a pause right here. We'll come back to the next section. We're going to start implementing this validation mixin. In the last section, we spoke about how we could reuse that validation logic by putting together a new class that we're going to call validation mixin. So in this section, we're going to create this mixin and then link it up to our login screen state. So I'm going to get started by finding my src directory, and inside there, I'm going to make a new folder called mixins. So we're going to make our own separate folder to house every mixin class that we have. Then inside of here, I'll make a new file called validation_mixins.dart. Excuse me, validation mixin singular, just validation mixin. Then inside of here, we'll define a class called validation mixin. And then to this class, we're going to add in a function that we'll call validate email and validate password. So I'm going to flip back over to my login screen. I'm going to find my first validator function tied to email field right here, and I'm going to cut the entire thing. Then I'll flip over to my new mixin. I'll define a method called validate email, and then I'll paste in that entire function like so. And then the only change I'm going to make here is I'm going to annotate validate email as returning a string, like so. Now, when I annotate the return type right here of string, you'll notice that we're now seeing a warning saying, hey, you don't have a return statement in here if you don't enter the if statement. So when I put on that type annotation, I do have to put in return null like so. And when I do so, that warning goes away. Okay, so now we'll repeat the same process with our password validator. So here's my password field. I'll find the validator. I'm going to take that entire function. I'm going to cut it. I'll flip back over. I'm going to add in return type of string, validate password, and then paste what I had just cut. And then I will again add in the return null at the bottom. Okay, so this looks good. We've now got our validation mixin. We can now import that validation mixin over to our login screen state file, and we'll form the link between the two. So I'm going to flip back over to my login screen. You'll notice that our validator fields on both password field and email field are blank. We're going to fix those up in just a second. Let's first import the mixin we just created. So I will import up one directory, mixins, validation mixin.dart. And then finally, to take all the functionality, all the functions that we added into that mixin and add them into our login screen state right here, I'm going to find the login screen state declaration. And then after the extend statement, I'll add in with, and then the name of the class I want to mix in, which is going to be validation mixin, like so. I'm going to collapse the sidebar so we can see the whole line. So now we're saying create a new class called login screen state, extend all the functionality from the state base class, and also give me or copy paste all the methods coming from validation mixin into login screen state as well. So now inside of login screen state, we can freely reference the functions that we defined inside of our mixin as though they were directly defined inside of my class. So if I go down to my email field, for the validator right here, I can say anytime we need to validate this thing, just run the function validate email, like so. Notice that I do not have my parentheses on here because I'm not trying to invoke that function. I want to pass a reference to the function validate email to the validator. So validate email right here is coming from my mixin. Now I'll go down to my password field and I'll do the same thing with this validator as well. So validate password. Okay, that looks good. I'm looking at my sidebar over here where I normally see errors and I'm not seeing anything. Everything looks pretty good. So I'm going to do a quick refresh and I will test this thing out one last time. So quick restart, or I guess slow restart, depending upon how you look at it. So I'm going to enter my email in. I will put in a password. I'll submit, and I'm good to go. But now I have some very reusable validation functions that I can use inside of any form that I create inside of my project. So definitely a great way to get some code reuse going. All right, so this looks great. I think we're just about done with this iteration of our login form. So let's take a quick pause right here. When we come back to the next section, we'll start talking about how we're going to implement that block pattern. So quick break, and I'll see you in just a minute.